Hi. Um, in this lecture, we're going to look at literature reviews in specific, how to review the literature. So I'm going to give you a few suggestions for approaches to do systematic literature reviews that have been presented in papers that aim to try and guide researchers as they carry out their literature reviews. Not only are we going to look at approaches, we're also going to look at the tools they use. So Google Scholar, for example, is an example of a tool that helps you do a literature review very effectively, as it happens. We're going to look at a few tricks of the trade as well, how people take shortcuts but still get the quality, I suppose, quality preserving shortcuts. First though, we're going to have a look at that paper on oralization I gave you at the end of week 1, and we're just going to do a quick review of it. Now, I know you've all sent me in paragraphs on the summary, the critique, and the structure of the paper already, and I will be giving you individual feedback. This is my feedback as if I did the exercise that I had given ye, and you should be getting your individual feedback later on in the week then. So, what would I say the summary of the paper was if I had just a paragraph to summarize the paper? You can get distracted here by lots of stuff, but the essence of the paper is they're presenting an auditory visualization system, and specifically they're assessing if that auditory visualization system can assist novice programmers in debugging code. So they're looking at an approach where programs are auralized. You get a aural ear-based representation of your code base, and does that ear-based representation allow novice programmers debug their code easier? Now that phrasing, novice programmers debugging their code easier isn't very measurable. We need to find some better measures for that. So they break that research agenda down into more specific research agendas. Easier means that they could probably detect more bugs. Easier means that they could detect those bugs quicker. Easier means that their perceived workload would be less. So, in fact, they target 4 specific research questions: that novices detect more bugs with their auditory visualization system, which is called Kaitlin. That novices will take a shorter time to find bugs with Kaitlin than without it. That the perceived workload will change, that presumably would be decreased with Kaitlin, and that musical experience would not help. While this doesn't target the core findings of the paper, it does sort of aim to profile the users who would find Kaitlin useful. If you need musical experience, then only musicians need apply. If you don't need musical experience, then Kaitlin is open to everyone. What did it find? It found that novices detected more bugs with Kaitlin's auralizations than without. That it didn't take any longer or shorter to find the bugs. That it was about the same. But that people who were using Kaitlin found their perceived workload increased. And they also found that Kaitlin was open to all participants. The musical experience didn't really help or hinder. So the essence of the paper really is that second point, assessing if Kaitlin's auditory visualizations of programs can assist novice programmers debugging code. It suggests that they can detect more bugs, but not that really that it shortens the time taken to find bugs, or that their workload decreases and indeed the perceived workload increased, and that it's open to all programmers. What's interesting, if you look at the paper itself, here's the abstract, is that an awful lot of that is contained in the second paragraph of the abstract. And that's ideally the role an abstract plays in the paper, to give you a summary of the paper at the top level. In this paper, we describe how the Kaitlin system was used to study the effects of musical program auralization on debugging tasks performed by novice programmers, Pascal programmers. The results of this experiment indicate that a formal musical framework can act as a medium for communicating information about program behavior, and that the information communicated could be used to assist with the task of locating bugs in faulty programs. So you see you're getting a general overview of, you're certainly getting that point there. You're not getting maybe the specific findings, but they are saying it helps in some ways. You can detect more bugs. It doesn't give the specifics though. Okay, so moving on to the critique. Well, by critique, I think there's a tendency to say critique means what's negative about a certain artifact. Critique actually means what's negative and positive. So some of my points are going to be negative and some of my points are going to be positive. I suppose the first point I want to make is a negative one. They are very targeted in what they go at in their programming language. So they look at selection and iteration, if statements and while statements specifically in the programming language Pascal. They look at limited bug types. In fact, they only really have one bug type. The control flow of the program changes. So in terms of an if statement, it says it goes into the if statement sometimes when it shouldn't, or it bypasses the if statement sometimes when it should go into it. In terms of iteration, it jumps out of the iteration at the wrong time. So you're talking about error types that deal only with the control flow. That's very scoped all of a sudden. You're only dealing with control flow errors, not memory allocation errors or memory accessing errors or any other type of error. And that means that their findings aren't as general, that oralization can't tell you all about all programs. This study only tells you about one aspect of programs' control flow, and in two different contexts, selection and iteration, if statements and while statements. Now, to be very fair to the authors, they hold their hands up and they put that right up front. They say these are the sort of bugs we're dealing with. But they are very limited bug types, and it does raise the question in the back of my mind, do these oralization environments, is there enough of a language in music that people could latch on to quickly enough to make them portray all aspects of a program? You can imagine that in portraying all aspects of a program, you'd be dealing with a symphony of music with many different instruments coming in and portraying many different things. Would people be able to follow that symphony in terms of its meaning? There's an awful lot of programming concepts. There's music being intuitive enough to capture the error in that symphony of sound that you're hearing. So I suspect that oralizations might be good for presenting one aspect of the program, or two aspects of the program, but not for representing all aspects of the program and all possible bugs that could happen in the program. So that would be my first thought on reading it. And I suppose that would send me in a new research direction. How could you describe programs using oralizations that are rich enough and yet intuitive enough to be followable by the reader or the programmer? My second comment is that, well, it's a positive comment actually, that the basis or rationale is really well presented in this paper. If you look at the introduction, you'll find very strong rationalization for how or why the authors believe that sound may be useful to programmers. You can see my comment just here, because sound can carry information in parallel streams. So you can have your visual attention directed at something, but sound can be giving you another source of information. Take, for example, the classic surgery scenario where you're hearing the beep in the background, but the surgeon is working on a person's body, the beep representing the heartbeat. It's very clear when that beep changes to people, and they're very alerted to it, even though they may be concentrating very much so on what's in front of them in terms of the person's body. Also, from psychological theory, we know that sound, especially music, has good persistence in the short-term memory. So it's likely that oralizations can provide us with ancillary information that's really useful to us, that stays with us in short-term memory. So that's good rationale for why you might suspect that program oralization might be a really good thing to do. So that's a critique that is positive. And indeed, they're very upfront about the scoping issue here, so that's sort of a critique that's covered, I suppose. My third point is about workload and musical ability assessment. So they had an assessment technique for workload and assessment technique for musical ability. I want you to have a quick look at those if you haven't noted them already, and note the difference between the two of them. I'm going to pause for a few seconds now so you can pause the video and do that if you haven't done it already before I make my point about them. 3, 2, 1. Okay, I'm back now. Um, so what's interesting is they use the NASA TLX workload model, perceived workload model, and questionnaire when they were assessing workload effort. And that's a very standard, probably very rigorously accepted workload questionnaire. Uh, but when they were assessing musical ability, they seemed to pick questions out of the air a bit. I think there was one there about singing in the shower in terms of musical ability. So while this is quite standardized, I'd imagine, and accepted by the community, this seems to be their own and not very accepted. So they're not really standing on the shoulders of giants here, where they are really standing on the shoulders of giants here. They've used a technique that's accepted before. So I would say that their workload modelling, or their perceived workload modelling, is very strong, whereas their musical ability modelling, that seems to be quite weak. So that would be a problem for me in terms of their finding with respect to, does your use of Kathleen depend on musical experience or not? Okay, next question for you is, why was there one Eastern student in the empirical study mentioned? Have a think about that for a second before I move on. I imagine it's because Eastern students might have a very different sense of music or cultural musical background, and as a result they'd have very different cues in music and familiarity with music. So I think it's probably good they mentioned that there was one Eastern student. It would have been interesting to hear a bit more about that particular student's results, but I guess that would make the student very identifiable, seeing as he was the only Eastern student in the class. And finally, I want to talk about another positive comment, which is the within subject design. You'll find that on page 26. You see here within subjects design. What does that mean? It means that for every subject they had some bugs with the oralization and some bugs without the oralization. Okay, now that we know what it means, do we think that's a good design or a bad design? Have a think about that for a second. It's very definitely a good design, because it means that you've coped immediately with the individual variability that can occur. Like, you can have a good student and a bad student. The good student would probably find the bugs quicker than the bad student, and that difference would probably overpower any difference of the oralization. Because you let each student have some bugs with the oralization and some bugs without the oralization, you nullify that effect. So that's a really good design. So we say that within subject design is good. Noting the one Eastern student is good. The basis rationale is really well presented. But we do have some concerns as well. Specifically, the scope of bug types we're directing this work at, the musical ability assessment, and the fact maybe that they didn't talk a bit more about the Eastern student. And that suddenly raises possible interest avenues for us. For example, we could maybe look at different types of errors in Pascal and see if oralization works effectively on those. Or, for example, we could get some standard musical ability assessment technique and see if their findings are replicated for that standard musical ability assessment technique. Another criticism is that the subject population is very male in its bias. I think of the 22 students they used, 20 of them were male. Now, of course, you can point to the fact that most software engineering, computer science type courses have that bias of male students, and the profession has that bias of male students, so maybe that bias is appropriate. But it might be interesting to note if oralizations work better for males than for females, and they didn't do any analysis of the 2 to the 20 people to see if that might be different. It's not implausible that there might be an effect there. Familiarization with the new oralization channel. Obviously, when something that new comes at you, hearing sound represents programs, that's very, very different, and it probably takes a little while to ramp up on that. So while they did have some familiarization tasks, there's probably scope for a lot more familiarization before that oral channel becomes really effective. You're essentially asking people to read for the first time here. You're taking a whole new communication medium and presenting them with it. So I imagine it might take a considerable period of time before they get to a normalized standard with it. And that might have changed the results, certainly with respect to the perceived workflow, and possibly even with respect to the number of bugs found, which sort of talks along the same dimension. You know, the harder it is to do, the time taken to find the bugs will be longer. One of the critiques that I thought about before I got it in the paper, they actually addressed it in the paper, was what about non-musical oralizations? Music, yeah, it's very good for certain things, but is it good for this? Why not just text? Why not beeps? Why not other icons, oral icons? Having said that, they do acknowledge this as potential future work going forward. So I think, to be fair, it's covered by them, but it is something that again prompts maybe we could do better using other oralization techniques. In terms of the structure of the paper, I want to point out a few things to you. Well, first is the very explicit structure. We've got an abstract up front, then an introduction, an objective, etc. all the way through. But I want to talk to you about the more implicit structure. So rather than the explicit sections, what each section attempts to do. So the abstract, first and foremost, if we just whiz back up here, there we go. As I said before, it gives an overall feeling for what the paper does, particularly in the second paragraph. The first paragraph is a bit of a, well, it's interesting about the cricket that chirps at different rates proportional to the temperature. But the core really is in the second paragraph, how Caitlin, the oralization system, can show stuff about programs and help debugging novice programmers. So abstract really means article in a nutshell. Then the introduction, well, its job really is to motivate, and I notice here that they've taken the introduction and the objective and put it into two separate sections. Most people would put what they've put in the first two sections into one, which is a sort of an introduction. They'd say the introduction should contain a motivation, and you can see the motivation down here. Sound can carry information in parallel systems. Sound is good at has good persistence and short-term memory. But there's also more motivation here. If you look at this text here, it talks of how there's a research area out there with other people looking at this sort of stuff, and even down here later on in the motivation or in the objective section, they're also talking about other work in the area. So it's an interesting academic area, but they point out that there's very little empirical study done in this area, and so they're going to assess whether these musical representations would assist novices in bug location tasks towards addressing this empirical deficit. So just to summarize, the abstract gives the summary of the article in a nutshell, so it's very good if you just want to check if it's relevant. And then the introduction gives the motivation for the work and the objective for the work. And you can see the objective there, and I've talked about the motivation beforehand. Then, in section 3, they do something that most other papers do a lot later, which is talk about the imposed constraints, the scope of the work. So research is not about selling your work, it's about stating exactly what you did and exactly what you didn't do. So these imposed constraints are that it only touches certain points of interest in the programming language. There's only control flow bug types in there. There could have been a few more that they could have pointed out. Like, for example, how they didn't have a good musical ability test. Maybe there is none out there for non-graded musicians, for example. But they could have talked about that as well. They left it very much at the scope of the programming language they were going to cover and the scope of the bugs they were going to cover. Typically, that would come later on in most academic papers. It would come after the empirical study, where you could talk about the limitations of the empirical study as well, for example. What limitations of the empirical study? Well, they dealt with very small programs. They dealt with novice programmers only. It doesn't generalize to serious commercial programmers working on large software systems. So you can see how you can bring in many more limitations later on in the paper when you've talked about your empirical study as well. And again, the point here is that you're trying to scope your work. The good academic work highlights its flaws as well as its achievements so that other researchers know exactly what has been achieved and, more importantly, maybe even perhaps what hasn't. Then the paper gets a bit more traditional. It talks about the work done, the empirical hypothesis, 4 hypotheses, one to do with the number of bugs, one to do with the time, one to do with the perceived workload, one to do with musical ability. Talks about the protocol it used to achieve those, and that seems fairly sound, if a bit artificial. You know, they're not the real working conditions of normal novice programmers, but still, it's a good way of checking the amount of time they spent fixing each bug, and the workload they spent, for example. So they discuss that protocol in detail, leading on to their results, and leading on to a discussion of their results, what their results mean. And this is a place where you can talk through the results, but you can also identify other things that happened with the data. So as we move through the discussion here, you see this paragraph here, which tends to lend a feeling that the more complex the bug, the better or more useful the oralization was. So here you can see a typical condition that novices might have difficulty with, to not equals to joined by an and where the bug oralization seemed to work better. I think I have another point down here which says exactly the same. Yeah, feeling that in situations where information is difficult to get at in program representation, oralization helps. But I have to point in that this is only anecdotal. They've only noticed this in a number of cases. But that discussion is an interesting discussion and something that's plausible. You know, if the representation, the textual representation doesn't help you, the oralization might be a good ancillary communication channel, like it is in the surgery where it records the person's heartbeat. It's interesting as well, just to go through the points in the conclusion. I've highlighted them. For programs of relatively high complexity where the output offers few clues about the nature of the bug, the oralizations appear to have a especially beneficial effect. Note the word appeared. Because they don't have very rigorous data on that, they can say words like suggest or appeared. They can't say did have an especially beneficial effect. Musical knowledge and expertise had no effect on students' performance. Musical knowledge as measured by the very flawed mechanism of measuring it. But yeah, the analysis of perceived workload shows that in the study the oralizations had a significant impact on the subject. This is not of itself an undesirable result if the final impact is the more bugs are located. And again, familiarity may have lessened that. Future work will attempt to define more precisely the relationship between oralized and non-oralized debugging with a view to creating a full oralized programming environment. My comment there is, I don't know if you can really believe that, a full oralized programming environment. Well, yes, you can have that full environment, but I don't think it's going to cover full programming languages and full programs. It is not unreasonable to hope that the system can be adapted and extended for use by the blind. Believe it or not, there are blind programmers out there, and this is obviously very appropriate for them. There arises then the question of scalability, that is whether or not the technique can be usefully applied to large-scale programs. I would wonder. Certainly, if it's going to be applied to large-scale programs, I suspect it's going to only be applied to specific aspects of it, not all possible bug error types. And here again it talks of a comprehensive musical program oralization system needs to be constructed to allow the mapping of all relevant program domain events to musical events. I imagine that would be overwhelming, as I mentioned earlier in my critique. The role of non-musical audio also needs to be investigated to find the best applications for each type of auditory display. Yeah, I came across that point myself and was happy to see it in the conclusion. I suppose one of the points that's interesting is I've constantly alluded to this overwhelming amount of musical data coming towards you. They do note that Jameson's sonnet system allows a threshold to be set for loops so that it is not necessary always to hear every repetition. In both systems, the programmers can also specify selections of the program code that will or will not be oralized. So here we can get very selective with what we're hearing about in our oralization, and that might be a way of abstracting away from all the detail of a complete oralization system. So you see they have a conclusions and future work section. The future work is sort of implied a lot of the times, but they do note it as they go. zooming in or out and abstracting from all the sounds so that you can get more of the program coverage and more bug types coverage through to full program oralization, and maybe even discussing non-musical oralizations that might be very effective, and they might be work that you might do. But you can do smaller tasks. For example, if we go back to our critique, you can say, what about other bug types? Let's take a specific other type of bug and see if an oralization would help it. Typically papers have sections with limitations in it. This limitation section came a bit early in the paper, and if I had a structural critique of it, it would be that the limitation section should really come after the empirical study so that you can discuss the limitations in your empirical design as well. Like the small number of participants, the small bugs that were used in the study, as in 5 or 6 lines of code, not a huge amount of lines of code. For example, the musical test that wasn't very standardized and didn't look very rigorous or scientific to me. So that ends our review of the Vickers paper. I just want to take a minute or two to review lecture 1 before we move on to lecture 2 proper. Just to note that with the Vickers paper, I will be sending you individual feedback on your individual comments about the paper before the end of the week. Okay, so reviewing lecture 1, what are the key messages? Well, the key message, I suppose, is that the research question drives everything. Derive it and scope it as early as possible. Now that'll involve repeated iterations back to the literature, refining it over time, but getting yourself a position that prompts a research question, and once you've got that research question, that will drive everything. Academic research is about advancing knowledge. To do so, you must know the state of the art, what there is evidence and strong rationale for, what there isn't, the points they make, the points they don't make, and subsequently you have to derive the research question that addresses a gap, a future work, or even a plain error in other academic work, other academic literature that hasn't been identified before. Subsequently then you have to disseminate that research. It's not research until it gets out there to the world and they know that knowledge has been advanced and how you have advanced that knowledge. So it's got to be clear, it's got to be transparent, it's got to be rigorous, and it's got to be disseminated out to the wider academic community so that they can evaluate it and see that knowledge has been advanced and how knowledge has been advanced, so they can then stand on your shoulders to move knowledge forward again. Follow the mantra of my PhD supervisor: read aggressively and write defensively. Very simple message, but a very important one. When you're reading other people's literature, you've got to find the gaps, you've got to find the errors, the inconsistencies. And only when you find those will you find things that people haven't mentioned, things that are just plain wrong, for example, and thus you will find a research gap for yourself. Of course, remember that if you're reading aggressively, so is every other researcher. So you've got to write very defensively. You've got to not sell your product as if it's, or your project as if it's the greatest thing that mankind ever invented, because it won't be. You've got to give what you've achieved, but you've also got to state very clearly what you haven't achieved. And that's what gets high marks. Writing scopeedly, within the scope, knowing what you have done, knowing what you haven't done, and making that transparent to the reader. Otherwise, people will read it aggressively and go, that's very flawed, it won't get published, or it'll get a low mark in its dissertation. In terms of academic research, the core central point is the theory, or the why things happen like this. It allows you to explain things that happened in the past, but more importantly, it might allow you to predict things that happen in the future, and being able to predict things that happen in the future is seen as very important in academic theory. That's a really successful theory if it can predict things that are to happen in the future. The importance of design in research. Well, what I mean by design in research here in this last point is that your empirical study, your information finding approach has to be very designed appropriately so that it does provide you the information you need. So you could do a big literature review that provides you with the information you need, but there are guidelines to doing that. You could design an empirical study where you bring in people from the street and they carry out some tasks for you, and that gives you the information you need. You can even design a software system that you think will work to do something novel and see if it does do something novel. That's important, but it's being able to have a design you can stand over that's really, really important. Okay, so we'll start with the literature review material in a second.